Hello and welcome to our today's webinar. The topic today will be our new weather sensors called WS700 and WS510 from the wind and weather section. So I want to explain first of all, of course, my own person. So my name is Manuel Kreissig and I will be your moderator today. As usual, of course, so I'm working in the hotline and service department at Lufft for 15 years now. And of course, if you need some other information, you can also send me an email. By the way, you will be also able to ask questions. We have a small question window on the right side of the webinar menu, and you can put your question inside that window. We will do a break at the end of the webinar, and then you can ask your questions. So first of all, advantages of the UMB technology of the, let's say, WS sensors itself. That's a general thing here. So the compact design for real-time weather stations is of course an advantage. That means we wanted to integrate all different type of sensors of measurements in one housing. At the end, the WS sensor family was born with the different versions which you can get from Lufft, and the new ones will be again the WS700 and the WS510. It's easy to install. That means that we normally use with our WS sensors, we use digital communication. That means all the calculation will be done inside the sensor. There is a microprocessor inside which will do all these calculations of the different values, and then you will transmit this easily via 2 wires. So that's the reason for the easy install and easy commissioning. Normally you only need 4 wires to set up the sensors here. We have one software protocol called UMB, which is an open protocol. So that means if people want to integrate this protocol to their own systems, no problem, you can get this protocol from Lufft. Then we have a hardware interface, which normally will be used to be connected to the different UMB sensors, for example to the WS sensors, which is called Isocon. The Isocon normally will change the interface. That means the WS sensors and also the other UMB sensor will have a RS485 interface. And because it's not so easy to connect to an RS485 interface, we have this Isocon. This Isocon will convert the signal from RS485 to RS232, and then it's easily to connect this module to a PC or to a modem, or for example to COM server. The next point, calculation of all values direct in the WS sensors. Again, we have a microprocessor, and this microprocessor will do all the calculation. That means also that the transmission of the data will be done with a digital interface. Then we have the different protocols. In addition to our Lufft UMB protocol, the Lufft specific protocol UMB, we also have other protocols like UMB binary, ASCII UMB, Modbus, and SDI12, which are part of the WS sensor family. So if you have a system which normally uses SDI12, no problem, you can change the protocol using the UMB config tool, and then normally you will be able to connect it to the system. Firmware updates. Also firmware updates are possible with the WS sensors. We are RS232, that means you need an Isocon normally, and then you can do the firmware update directly on site. We will always have new updates on our website. That means please check frequently our website for new updates. New update means that we will have some improvements in the firmware, in the measurements, or for example also some new calculated channels which we will add to the new firmware. At the end, we have one software tool called UMB config tool, and this is the service tool which can be used to connect to all the different UMB sensors, for example also to the WS sensors. So that's the general information now. Now we're going into the WS700 here, and you see that's the, let's say, the latest WS sensor version with the most different single measurements. That means we have added one top part where we have combined the R2S, the radar range sensor, in combination with the global radiation sensor. And so I will show you that live maybe first, so how it looks like. So that's the WS700 here, and that's the special new thing here. We have here the the dome where the radar sensor is installed inside. So it's nothing else like a WS600 here, but in addition or in combination with the global radiation sensor here. This global radiation sensor here, which is a Lufft global radiation sensor, it's a silicium photocell which can be used to detect or to measure the global radiation here. So I'll switch back to the sheet. So global radiation measurement via pyranometer, between 0 and 1400 watt per square meters. So that's the maximum range. Normally you will never reach that on Earth. I think the maximum, if you have the best position, it depends on the angle to the sun, it's about 1300 and something. So normally you will not reach for 1400 watt per square meters. Normally it's about, if you have a really bright sunny day, it's about 1100. So that's the global radiation part here, which is combined with the radar part here. So the radar is nothing special. It's the same radar type like for the WS600 or 400. It's the R2S microwave Doppler radar, and it works like that. Here you will see the description how it works. It's a 24 gigahertz microwave Doppler radar, measures precipitation type and precipitation intensity by the correlation of drop size and drop speed. So we will measure the drop size, that means the volume of the drop, and the drop speed. And with this, in this combination, we can calculate the quantity of the precipitation, the intensity, and also the precipitation type. The precipitation types in special will only be measured by the speed. That means, firstly, so that means if you check the two diagrams here, we have one diagram for rain, we have one diagram for snow, and sorry, we have done a check of the rain events, and if we check different rain events, we have an average of the speed which comes, or in which the raindrops come down to earth, and that's normally about 4 meters per second. And for snow, it's about 1 meter per second. So see that here. And so that's how the sensor will clarify or find out if it's raining or snowing. So it will check the speed, and with the speed, he will put out if it's raining or snowing. That's how it works. So then we have, of course, here, this part is again heated. That means the radar rain sensor is also heated like the WS600 sensor. And yeah, also this heating is normally also used during summertime because we need an operation temperature of the radar, which is about 70 degrees. And so the heating for this type of sensor normally will also be switched on during summertime, for example, not only during wintertime. Then we go down to the next level, and that's the wind level here. With the wind module, we have 4 wind transducers installed on the WS700, like for the WS600 or the other sensors. And there are ultrasonic sensors, and of course the advantage is that they are very precise. We have a low startup value, and it's maintenance free. In the middle here, I will show you that live again. We have the mainboard installed. So normally between these two parts here, we have the mainboard installed inside, and on the mainboard we have the air pressure sensor installed, which will measure the air pressure. And what can be done here is that you can get the value for the absolute air pressure, which is calculated back to 0 meter sea level. And of course you can also get the relative air pressure depending on the real height of the sensor. If you want to use this, of course you have to enter or configure the sensor with the real height of the station. And then you will get the 2 different pressure types. So then we go down again 1 step here to this part, and you see this is the radiation shield. And of course radiation shield means that you are measuring normally here inside temperature, and we have a combined sensor. We will measure temperature and humidity inside that radiation shield. For the temperature we use an NTC, which is a resistance measurement element which will change its value depending on the temperature. And for the humidity, we will have a capacitive sensor element which works like a condensator, looks like a mirror, and if the relative humidity will be stay on the mirror, the capacity value will change, and with this change we will of course calculate the right humidity. So that's how it works inside. Of course, I told you that we have different heatings. We have a heating here also for the wind module. Oh, I forgot to tell you that. Of course, the wind module is also heated, but this will only be switched on during winter time. So it's regulated by the temperature, and the standard value here for the wind module is 5 degrees. But anyway, so if we heat up the complete complex here with rather rain and wind, of course, this will also influence the temperature measurement, right? So for that reason, we have, of course, a ventilated, aspirated radiation shield. That means we have a fan installed here inside, which will cool down the real temperature here to really measure the air temperature, the real air temperature, not the heating temperature, of course, of the device. I will show you that, how that looks like. So if you look down here, and you look here between the parts, then you will see the fan, the ventilator, which will cool down the complete part here, so that we will really be able to measure the road at the air temperature. Okay? Right. So, and then of course we have the data transmission. That means because we are using RS-485, you can extend the 2 wires for the RS-485 communication up to 1,200 meters and to communicate. That means only for this communication wires, not for the power lines, of course. Power lines, the maximum distance here with this diameter is 40 meters, not more. And then we have, of course, the different protocols like ASCII, SDI12, Modbus, and UMB. Right? Okay. Then here is the diagram how to connect the sensor. We have 6 wires which we have to use to connect the WS700. 6 wires because we have 2 wires, extra wires for the heating, which are the wires red and blue. Red is the plus 24 volts, blue is the ground. And the reason is that we wanted to have these wires extra from the main power wires, because we wanted not to heat up the complete complex also with these wires. So extra wires for the heating. Important is also that the heating is dimensioned for 24 volts. So if you use less than 24 volts, maybe 12 volts, then of course you will not get the full heating power, less than the half of the heating power of 12 volts. And that means also that during winter time, maybe it can happen that the sensor will freeze. So if you want to get the real complete heating power, you have to put 24 volts on these wires. It's different to the electronics power. That's the 2 wires here, brown and white. The electronics will start up with 4 volts and work up to 32 volts. So normally, of course, it was designed for 24 volts, but it can work between 4 and 32 volts. But only for the electronics, right? Then we have the 2 wires for the communication, which can be extended up to 1200 meters to communicate. Green is RS-485A and yellow is RS-485B. Normally, if you use a standard UMB station, you will connect this to an isocon, like shown here on the display, and then you will be able to connect this isocon, for example, to a PC or to a modem or to a COM server or something else. So that's how it works. I think that's it for the WS700. Let's go on to the WS510. Oh, wait. I want to show you, of course, how the sensor works in reality with the UMB config tool. So I will first switch to the desktop and we'll start the config tool. I will connect the WS700 now. Takes a little bit, but I'm ready in a few seconds. I have to connect the connector first. Now maybe you hear the the fan working. So now the WS700 is connected. I will not explain the UMB config tool very detailed because normally there is a special webinar which you can check on our homepage. So I will go to Edit, Sensors, then we will add the WS sensor. This one has the ID number 4 here in my case. So, and if you want to check if it's really communicating, you can use the Verify button, and then you will see Verify. Okay, the communication is stable. Then if you want to configure it, you mark the sensor in the list, in the selected sensor list here, go to the Configure button, and load Profile from Sensor. And then that's it. And now you're on the configuration menu. If you want to configure something for the WS, you can open this tab, WS-X-UMB, and then you will be able to configure. And you see, the UMB config tool will also automatically recognize the type. It's a WS700 here in this case. You have the general properties, which is one menu where you can change the ID. You have the communication properties where you can change all the communication parameters. And you have the measurement setup for the WS700 where you can change different parts of the measurements of the WS700. For example, something for the temperature humidity. Here you can change the offset, for example, or the interval for the calculation of min, max, and average. 10 minutes is the standard value. You can switch on or off the fan. Then you can go to the global radiation menu. There is nothing special to change here. It's only the interval for min, max, and average. Pressure, the same thing. Wind. You also can change the heater mode here. And you can also activate the compass. You can enter the local declination. So you see there is nothing special in the menu compared to the WS600. It's the same because, of course, the only thing which is in addition is the global radiation sensor. So it's a mixture of the menu of the WS600, for example, and the WS501. You have the rainfall settings, rainfall calibration values. External sensors can be activated only with the temperature sensor here because we have a precipitation sensor already installed. And we have the energy management where you can change the parameters for the power supply. If you don't know what you have done, you can always get back to factory settings with this button. So that's all. That's nothing special here. So you can go back to the main menu. And you see what was changed. Or normally I recommend if you connect a new sensor type like WS700, and you have used the UMB config tool before with older sensors, and you have to do an update channel list. That means with the update channel list, you will read out the new channels maybe which are implemented in the new version in your software. So we will do it together. Nothing will change, by the way, because I have done it before. So it was changed from 117 for the WS600 to 119 for the WS700. But it looks like that. So use the button, then the channels will be read out from the sensor, and it will be displayed now here in this small window. 119 channels can be activated at the end for this WS700. If you want to activate some of the channels to check the values, so again, you don't need to activate something to work with the WS. It's only if you want to see it now on your software side, you can activate the channels here by double-click on this menu, Active Channels, double-click. Then you can activate the channels you want to see, for example, temperature, and you click on inactive, and then it will be active, it's green, and then this is active. Then you can click on OK, save and exit, and you can start the measurement, and then you will see the actual value in the temperature, for example. Of course, you can add more. It's only an example here from my side. I don't want to show you now the UMB config tool. It was only, I wanted to show you how the menu looks like for the WS700, which is nothing special. Okay, so I will stop the measurement now. So we are going now to the WS510, which is a special sensor because, of course, you know that we have the WS501 and, of course, the 301, which have a Kipp Zonen global radiation pyranometer installed, the CMP3, which is, by the way, a second-class classification sensor. Because we were often requested if we cannot use a higher quality global radiation sensor, for example the CMP10, we have now included the CMP10 in the WS510, which is you see that here on the sheet, it's a global radiation measurement via secondary standard, not second class, it's secondary standard, which is one of the highest level which you can use to measure global radiation. Secondary standard pyranometer, Kipp Zonen CMP10. And in reality it looks like that. So that's the sensor here from the top, so I'll show you from the side. And you see what is included here is that you have here a water level. And to reach the best performance of the sensor, you have to put the water level in the right position. And if you have installed the sensor on the pole, on the mast, of course you can use here a wrench to put the different screws here. We have three of them in the right position, so that the water level here will be in the right position too. And that's really important. You have to do that if you want to get the best value performance, measurement performance, okay? The sensor itself uses thermopile measurement element. That means inside here, the dome, we have an amount of thermocouples which will measure the temperature. And of course, because it's heated up by the sun, it will also be higher temperature. Inside the CMP10 we will have a reference temperature measurement, and these two measurements will be compared. And with the difference we can calculate, or the sensor can calculate the global radiation. Okay? That's how it works. And then of course we have here the wind sensor element. That's the standard wind sensor module. We will have also the air pressure here inside. We will have the temperature humidity sensor inside here in the radiation sheet. So it's the same like the WS700 before. So we will see that here. So we have the global radiation measurement via the Kipp Zonen CMP10. We have the before I think I will show you the difference between the CMP10 and the CMP3. So these are the technical details for both sensors. And you see the 510, that CMP10, has a lot better parameters than the WS501. If you compare the response time, for example, 5 seconds, to CMP3, 18 seconds. The non-stability value, change per year, 1%, to CMP10, 0.5%. And so on. Non-linearity, 1% for the CMP3, 0.2% for the WS510 for the CMP10. Directional error at 80 degrees with 1000 watt per square meters, under 10 watt per square meters. For the CMP3 it's under 20 watt per square meters. So it's really a different quality level here. So that means for solar parks, for special customers who need some accurate global radiation measurement, this CMP10 WS, called WS510, is recommended from our side. Alright, so back to the main sheet. So we have the wind speed measurement, and direction measurement. It's the same like before. It's an ultrasonic wind module with 4 ultrasonic transducers. The same thing, low startup value, maintenance free, very precise. Air pressure, the same thing. You can get both values. You will get the absolute air pressure. You will get also the relative air pressure if you enter the height of the station, of course. Then measurement of air temperature, relative humidity inside the radiation shield, and the radiation shield is also aspirated and ventilated. Of course, the WS510 only uses one heating, because we only heat up the wind module here, nothing else. Okay. Data transmission, the same thing. Data RS485 interface, and the same protocols, of course. Then the connection, also there is no change between WS700 and WS510. By the way, also for the other sensors. So we always have 6 wires here, 2 wires for the heating of the wind module in this case, then 2 wires to power up the electronic part, and 2 wires to communicate. The same wires, the same colors, everything the same. Of course, also the interface can be used. It's the Isocon again. So I will do the same now with, like before with the WS700. I will show you how it looks like if you connect it to the UMB config tool. So let's switch back to the UMB config tool. Open it. Edit sensors. We will add the WS6UMB, in this case with ID1. Again, double check if it's really connected with the verify button. You see it's okay, verify okay, so it's connected. Now we can go to configuration, low profile from sensor, and here we are. You see now again we have the measurement setup for the WS510, and you see there are less tabs here, of course, compared to the WS700 because we have no precipitation measurement, of course. So we have tabs for the temperature, humidity, where you can change the parameters, for the global radiation, for the pressure, for the wind, for the external sensor. Here you have more options, of course two, because you can add an extra rain gauge if you want, or temperature sensor. And of course the energy management. So that's it. That's really easy, I think. Let's go back. Main menu. Same thing also for the channels. It's the same thing like before for the WS700. So, have you some questions? Do you have some questions? If so, please send or put your questions in the small box, and I will try to answer them. So, first question is the same webinar as we got invited to on 16th of April. No, of course not. I think you have to differ a little bit. This is a webinar for all the people. On 16th of April we will do a special. It's it's a training. Yeah? It's an online training. It's not a webinar. So please don't mix it up, okay? That's a special thing, and we will talk about it anyway later, not in this webinar. So please tell me questions about the products here we talked about. Is Isocon have any protection for DC power or for RS485? The Isocon, of course, is protected. It has some diodes inside, and it's also galvanic isolated, by the way. So, but it's not a protection against overpower. Again, you cannot protect that. You need, if you want to protect the complete devices inside a cabinet. We are talking about a cabinet, inside a cabinet. You have to use an external and special overvoltage power protection. By the way, the sensors cannot be protected against overpower on the pole. Of course, they have some diodes and everything inside, but if the lightning strikes there is no security. So again, next question. So there is a question, we have one question, is it possible to request data from, for example, WS700 via LAN from local user PC but without Lufft data logger using Lufft collector software application? Of course. If you connect the WS sensor via Isocon, for example, to a COM server, you can of course connect to the COM server with the collector software and then read out the WS700 values. Why not? That's not a problem. And of course, if you don't want to use the Isocon, you can use also your own converter. Or you have a COM server which directly can be connected via RS485. Then you can also directly connect the WS to the COM server directly. So no problem for that. Something in the radar, they work normally or have some problem in the measurements, birds, dirty or paint. No. I can switch back to the camera. So I will show you again the WS700. No, of course there is no problem with birds or something. First of all, I told you, it will always be heated. That means if you use it with normal heating, this dome will be heated up to 70 degrees. So it's so hot that the birds will not like to sit there, first of all. It's funny, but it's like that. But also there is no problem, because if there is some dirt, that will not influence the measurement. And of course, if it starts to rain, anyway, it will be cleaned again. So it's really maintenance free. That's how we sell it. And there is no influence from outside normally, only if you have some waving parts. So that means the waving parts like breaches, which will act like velocity. And that means if the breach of a tree acts like a velocity over the sensor, that means like that. I'll show you like that. Then of course the sensor will measure something like precipitation, and then you will get a precipitation output. So that means normally if the sensor, let's say around the sensor you have nothing installed, then it will work without problem. So it should not be nearby the tree or some plants or something like that. So which silicon sensor? And if we have some dirty spray or paint in the ultrasonic sensors, so of course if the ultrasonic sensor is covered, that's very bad. That means that's also the reason why it's heated during wintertime, because if during wintertime there will be one ice layer over one of the measurement elements laying like this and covering one of the elements, you will get no values anymore. So these ultrasonic elements have to be free always, okay? No paint, no cover, nothing. They have to be free. So next one, which silicon sensor is built inside the WS700? There is the silicium photocell which is used here. I think you mean that one. It's a Lufft special developed sensor. It's a Lufft own sensor. It's not a Kipp Zonen or something like that. That's a Lufft internal sensor. Okay. Okay, next one. Is it monocrystalline or polycrystalline? I do not know what that is. Sorry for that. I'm not a global radiation specialist here, so I do not know if it's, but I think it's not important, by the way, anyway. So next one. What is the accuracy of the silicon? We can double check I will double check the technical specification here. Of course, it's not so accurate like the CMP3 or the CMP10, of course. So the accuracy of the Lufft silicon photocell is 5%. Okay, that's the accuracy. Okay, additional questions? All right, so I think that's all for today. I want to thank you for your interest, for all your questions. It was a pleasure for me, of course, to give you all the information about the WS700 and 510. If you are interested, we will have some new webinars in the future, end of March and beginning of April, about Marvis. We will have another hardware webinar and another software webinar where I will explain all the Marvis stuff. So I want to invite you to these webinars too. If you have some time, please register, and I hope you had some good information today. Thank you very much, and bye-bye.